Hello students, this video is for Unit 1, Lesson 2. It's the lesson on complementary and supplementary angles. We're going to be talking about different types of pairs of angles, the relationships between those pairs, and then once you know the relationship, what you can do with it, specifically what type of equation you can put it in. The first thing that we have to do is take a look at the learning target. In this case, it's applying definitions of complementary and supplementary angles to find missing angles. So that gives you a little bit of a clue. We're going to be finding missing angles, doing a little bit of algebra. The do now is to identify the difference between a line and a line segment using full sentences in your response. Take a few seconds to try to write down what you think the definition is or the difference is between a line and a line segment, and then come back to see if you got it right. All right, here's your two line versus line segment definitions. There's actually three different aspects of the differences between the lines and the line segments. Lines are a straight set of points that extend infinitely in two directions. That infinitely part is the part that we're looking at. But a line segment is a straight set of points that has two specific endpoints. Since it has two specific endpoints, that means it's not infinite, it's actually finite. Speaking of infinite versus finite, infinite means you can't measure its length. You cannot measure its length because it goes on forever. What's the length? Infinity. However, a line segment is finite. It stops at each endpoint. You can measure its length. Easy enough just by using the distance formula or Pythagorean theorem or some other method. Third of all, a line is named using any 2 points on it. So if you pick any 2 points along a line and say, well, I'm going to name it using those 2 points, you can. Whereas a line segment, you must name it using its 2 specific endpoints. Doesn't matter the order, but you must be using those 2 endpoints. To show you a quick example of what I mean, this line, which is named, well, it could be named a lot of different things. It's got 4 different points on it, and you could call it line LP, you could call it line MP, or you could call it line NL. All we're doing is choosing 2 points that the line passes through, and that is a valid name for the line. There's actually no rule that says you can't name it with more than 2 points. You can name it line LMP if you want, or LMNP, as long as we're going in order here. It doesn't matter whether you use 2 or 3 or 4, as long as you use at least 2. So all of these names refer to the same line. However, with line segments, it's a little bit more restrictive. When I'm looking at this line segment, for example, I can name it line segment JM or line segment MJ, but I can't name it anything else. As a matter of fact, if I tried to name it something else, I would be talking about a different line segment. For example, if I tried to name it line segment JL, I'd only be talking about this line segment, the distance between, or the set of points between J and L. It would be a different line segment then. Lines are all the same because it continues on forever, but line segments are all different based on the endpoints that they have. Moving on to the actual lesson today, I'm going to be talking about all sorts of different definitions for angles, and the first definition I want to talk about is right angle. It's a angle term that you've heard before. It's the angles that are 90 degrees. So like I said, it's an angle that measures 90 degrees. In a diagram, you'll see this box in the corner. That is the symbol for right angle. It indicates that the two sides of the angle are perpendicular. This is a word that you learned about in algebra. So we would say that angle DEF is a right angle. A linear pair is another different definition, which you'll see right now. Now, linear pairs are two angles that are adjacent to each other and whose sides form a straight line. You can see that straight line here from A to C to B. There's your straight line. As a quick note, adjacent, that word means next to each other. Adjacent angles, they share one side. So you can see that this is the shared side between angle ACD and angle BCD. One thing that I want you to add into your notes, oftentimes you'll look at a diagram and you'll see two different angles. And what we usually do in geometry is we'll indicate that angles are different by having different numbers of arcs. This little curved line here is an arc. So I'm going to use one arc here to represent this angle. This angle over here is clearly larger, so I'm going to use 2 arcs to represent that. So I'm just going to draw in another arc. On your notes, go ahead and draw another arc here to represent the fact that I don't know what the measure of angle DCB is. I don't know the angles measure for ACD, but I do know that they're different measures. So 1 arc here, 2 arcs here, just to represent that the fact that they're different. Complementary angles are a special type of adjacent angles, which we'll give you the definition now. All right, so-called complementary angles, they're not angles that say, oh, you look very nice today. They're angles that are adjacent to each other and whose sides form a right angle. So this angle here and this angle here, if you put them together, you would recognize that they would add up to 90 degrees. In other words, they would form a right angle. Incidentally, the formula that we're going to be using, or the equation that we're going to be using, is the sum of the angle measures being 90. In other words, the measure of one angle plus the measure of another angle is equal to 90 degrees. I'm going to walk you through how that's supposed to look. Last but not least, we'll talk about supplementary angles. All right, supplementary angles are two angles that are adjacent to each other and whose sides form a straight line. Once again, if you were to take the angles here, this angle which we named angle C, and this angle which we named angle D, if we were to add those together, or if we were to put them adjacent to each other, you would see that these angles form a straight line. One thing that you should know about straight lines is that on one side of a straight line, the sum of the angles is 180, so that gives us another concept or another conclusion for a supplementary angle, which is that the sum of these angle measures is 180 degrees. So this is a two-way street. If I can identify that two angles are complementary angles, then I know that their sum is 90 degrees. And if I can prove that two angles have a sum of 90 degrees, then I can say they're complementary angles. Same way with supplementary angles. Moving on. In the model problems, you'll see that there are use of vocabulary words here. For example, here we talk about complementary angles, and here we talk about supplementary angles. Take a few moments to look over these problems and try to think of what to do first. I'll let you pause the video and then come back to see an explanation. All right, when I see the word complementary, I think to myself, well, complementary means the two angles combine to a right angle. So what I'm going to do is I'm going to just draw a right angle. It doesn't have to be any specific right angle. I'm going to draw it just like this so that it has a right angle here. And it says that angle A and angle B are complementary angles. I don't know where I should split this up, but I know that angle A and angle B are going to be next to each other here. So I'm just going to draw any old line. It doesn't really matter because this diagram is not necessarily to scale. I'm going to label this as angle A, and I'm going to label this as angle B. I guess I should include angle in there so I know what the heck I'm talking about. All right, so I'm told that angle A and angle B are complementary angles. That looks like the setup here. I'm just going to add in the box down here that represents right, and there's that box so that everybody knows what we're talking about. Okay, I know that complementary angles add up to 90 degrees. They sum to 90, which means if I know that I'm going to be using complementary angles in this problem, I'm going to tell the person looking at my paper, tell the grader, in other words, that I'm using the concept of complementary angles. So here's how I do it. And what I've done here is I've just written down a fact. Complementary means that angle plus angle equals 90 degrees. That's something that we know. That's what complementary means. So I'm going to start off with that fact. Next, I'm going to try to take the information that I know and substitute that into this fact, into this equation. It says that the measure of angle A is equal to x. Well, I know that the two angles in this situation that I know are complementary are angle A and angle B. So I'm going to fill that information in. Angle A plus angle B is equal to 90 degrees. I'm also told up here that the measure of angle A is equal to x. So what I can do is substitute in x for where I wrote the measure of angle A. And incidentally, that M stands for measure. So that means that x plus angle B is equal to 90 degrees. The nice thing about this is it's an equation. You went to school for equations. That was the whole point of algebra and the whole point of 8th grade and probably other things that you've done in your life. However, the reason that we're writing it out as an equation is because you can solve an equation very easily. Now the question is asking which expression represents the number of degrees in angle B. That's what it wants to know. Angle B is here, so in order to solve for angle B, I need to subtract the x from both sides. I'm going to use opposite operations. So subtract x from the left-hand side and subtract x from the right-hand side. That means that angle B is all alone on the left-hand side. That's equal to, since these are not like terms, I'm going to write it as 90 minus x. And couldn't be easier, couldn't be simpler. I found my answer, 90 minus x. How about that? The next problem is very similar. We're going to draw a diagram, try to apply the vocabulary word that we know, and solve an equation. Take a moment to try that out, and then come back for the answer. All right, based on this word supplementary, I knew that the two angles must form a straight line, and they must be adjacent to each other, so I drew this diagram to represent that. And it says the ratio of two supplementary angles is 2 to 7. What that means is, whatever this angle is, it represents 2 parts, and whatever this angle is, it represents 7 parts. There's another way to write out this algebraically, and I'll show you right now what that is. One piece of information you should remember from algebra is if you have a ratio of 2 unknown values of, let's say for argument's sake, 2 to 7, that means the first unknown value you can represent with 2x, and the second value you could represent with 7x. That just means there's an unknown scale factor between the two numbers that we don't know, so we can represent that unknown number with x. So now that we have this information, the two labels, we can use that supplementary concept to try to write an equation. Turns out that the only difference between complementary and supplementary is that complementary adds to 90, supplementary adds to 180. No big difference there except for the number. Now, since these two angles add up to 180 degrees, I know these two angles, so I can take them and substitute them into my equation. The first angle being 2x and the second angle being 7x, not really caring which one goes where because of the commutative property of addition. Well, 2x plus 7x, that's 9x. So I can say that 9x is equal to 180. And then in order to solve this equation, I can divide both sides by 9. A very easy proposition, x is equal to 20. So the measure of x, this value, is 20. Now keep in mind, we're asked a different question. We're asked for the measure of the smaller angle. Well, the smaller angle of these two, between 2x and 7x, is definitely going to be 2x. So in order to find the value of this angle, we're going to take this x value, x equals 20, and substitute it into 2x. And it's easy enough to see that when you substitute 2 times 20, you get 40. So there we go. Our answer is D, 40 degrees. This was our video on complementary and supplementary angles. Hopefully you learned something. Good luck studying.